All right, thank you. All right, good afternoon, everyone. My name is Muhammad Harun, and today I would like to talk about how and why to build a security operations center. So what happened is we have a security operations center that we created and built within Intel, the whole enterprise, and we'd like to share some of those experiences with all of you. If, let's say, you want to consider to create your own SOC later on, all of these experiences will help you. So for the agenda, we're going to talk about the problem statement, why we need SOC, the solution that we can come up with, and then what we learned while we implementing the SOC, conclusion, and we also have backup information if you need. So everybody knows that for a big enterprise, each company, they need to have somebody to look and monitor the enterprise. We got firewall, you got IDS system, you got authentication system. All of those will create logs, and you need to have somebody to look at it. Otherwise, it will not be useful. So when you look at who actually the best people to do that, to look at all your security logs, first of all, this is not a job for the security. This security job is not for system administrators or network administrators. What happened is they need to do more on availability. Their job involves making sure that the system's up, the network is up, and they do not have any time for looking at the security events. The other thing is they do not have adequate separation of duties. If, let's say, they have administration access to the server, to the network routers, at the same time they need to take a look at the security events, the logs, then the separation of duties is actually not happening there. And if you actually bring up the case to a court, they might say, hey, you might have changed that. This is not actually from the suspect. So this is very important, that the separation of duties is kept all the way during the investigation, during the detection, and so on. So the solution that we can come up with is to create one dedicated security operations center. And we have like a dedicated resources, dedicated team to do this job. Intel environment is basically a very large and distributed network. We have more than 100,000 nodes across the globe, all over the world. And we have a lot of operating system, a lot of sites across the globe. And all of those are actually connected via multiple protocols. And many of those, actually the sites, the groups, the departments, they have their own priorities and requirements in terms of security, the availability, and a lot more. So because of that, there's a lot of development work, right? Development work and custom applications done for specific groups. And for that, that is one of the big challenges that we are facing. Where can you find SOC? There are three options available for you. One is outsource it. Second is you can create individual groups within the organizations. If, let's say, you have engineering groups, then within the engineering groups you have one SOC. You have HR groups, the HR groups has their own SOC, and so on. The other thing is you can have one central team to perform the monitoring for the whole company. The advantages of outsourcing the SOC. First of all, they have the team that's actually dedicated doing the job. And usually when you give this job to the managed security services provider, they have the teams, qualified teams to do the job for you. They will basically monitor that. And this could be cheaper for you rather than creating your own SOC. The other thing, one most important one, is less potential of collision between the monitoring team and the person or the suspect that's attacking the environment. If let's say you have insider attack, and the person who actually attacking your environment is a friend, a good friend of your team, then what happens is it creating much more stress, and sometimes the ethics will be violated. They will not report it, they will keep it to themselves, and so on and so forth. So having managed security services doing the job for you, you can avoid these kind of issues. The disadvantage of having MSS doing this for you, when you have a very large environment, you have a very diverse environment, they might be technically very competent in terms of doing the job, but they might not know about your environment. Let's say if you have Windows environment, if you have Unix environment, you have VMS environment, all of this actually is quite diverse for some of these people. They might know how to detect certain things, but they might not know about your environment themselves. So sending the job out of the company can also be a bad morale for the rest of the team members. Seems like the trend nowadays, when people are actually transferring the job out of US, for example, to a different part of the world, the morale of the team will be down. The other thing is there's no long-term gain for the company. You give the job to another company doing that for you. At the same time, what kind of growth in terms of knowledge, in terms of BKMs or best known method that we have learned from that, none of those actually you can learn because it's totally done by other people. The other thing is when you're doing intrusion detections or you're doing all these monitorings, it involves privacy. It involves looking at data that actually could be confidential and could be higher intellectual properties. So there is a possibility that might be a mishandling of the data by the outsiders. The advantage of having the internal groups, the second choice, having each department doing their own monitoring, they know their environment very well. They've been working in the environment for quite some time. They know the environment very well, and that is a very big advantage for the SOC team within the internal group. Because of that, the solution might be very customized, very much customized for that particular team. If they are basically Linux-based or Unix-based, they are basically customized for that kind of environment. They might not be able to do it on the other environments. The good thing is, because of that, lower cost to set up this kind of groups. The disadvantage, higher potential, because within a small department, small groups, they tend to have very close connections, close relationship within each of the employees. So there's a higher potential of collusion between detecting, reporting of the person or the suspect, and the analyst himself. So high potential for them not to report those. Inconsistent quality within the groups. This is in terms of the analysis and the skills, because each one might be having a different kind of backgrounds. The personnel are likely to remain dedicated to their tasks, because what they're doing is they're very familiar with the environment. They might not doing the security tasks that they're doing. Duplication of effort could be significant for it. And then you might be, while they're doing that, they're doing their administration stuff, at the same time they have to do their security monitoring. They might, most likely actually, will basically put aside the security work and just do their administrative stuff. So those are kind of the disadvantages of having internal groups within doing your SOC monitoring. The third option that you have is basically to have one dedicated team to do the job. One centralized team to do the monitoring for the whole enterprise, for the whole company. The good thing of having this one dedicated team, they can be very, very efficient in doing the job. They know the tools that they are looking at. They know the security logs they're looking at. they know the environment, and they can do a very good correlation between each of the tools that they are using to automate the detection. For that, they can basically able to enforce the quality of the analyst. The detection will be a lot better than the other two choices. By having them trained in not only in security, in intrusion detections, in firewalls, in network and other areas, you can actually enrich the employees, and as a result, actually, you can have a very good team. The disadvantages of creating SOC, dedicated SOC here, is one of them is the cost. The cost to have one centralized team is actually tremendous. While you have to set up the sensors for your IDS, for the whole network, for the whole enterprise worldwide, globally, that by itself is quite costly. And then you have to basically train them. You have to basically show up. That's basically the managers actually, they like to see the ROI. Once they spent all the money up front, within a few months or so, they would like to ask you, what's the ROI? What's the return of investment that we got from creating this SOC? So from this, there's a pressure for you to come up with something, right? So by having this SOC, it's actually a lot more advantages for you to have this team rather than the disadvantages. And it's a lot more, much better choices compared to the other two choices that we have. By having this team, we have much more potential to be more efficient. They know everything. They know. I'm going back here. Okay. So when you have the associate team, right? When you have associate team, centralized team doing all the jobs, doing the monitoring for you, do not mix up between the SOC and the NOC. Quite a number of people actually, they misunderstood when they have network operation center doing the monitoring for the whole network. They thought, okay, if let's say there's a warm outbreak, they will see that. Then they should be doing the same for the security. NOC is not SOC. First of all, the separation of duties need to be maintained. The NOC, Network Operation Center, all these analysts, they have administration privileges to the routers, all the network devices in your network. They have access to the routers, they have access to the switches, all this actually. So the SOC, they should not have access to anything. They should have access, only read access to all those logs, to all this information. If there's one incident, let's say there's an investigation going on, and they need to look at certain things, give them privileges only for that particular area or systems. Do not give them privileges for any other systems. So you keep the separation of duties. The second thing, the work is tremendously different between those two. The NOC, they are more into availability to make sure the networks are up and running, the LAN, WAN, all of those are available for people to basically keep the business running. But then the SOC, they are looking at the other side. They totally have different priorities. So when the NOC, their main duties is to keep the systems, to keep the networks up and running, their priorities are different, their duties are different than the monitoring. They will not, if let's say there's a clash between one, there's a network downtime, and the other one is there is a security attack. First thing they will do is bring up the network. That will be their first priority. So do not mix up between the SOC and the NOC. So what happened if, let's say, your management decided, okay, we already have NOC, why don't they go ahead and do the SOC jobs? And after you try to convince them, the management said, you've been told, okay, we are basically have finalized this, and we're going to go ahead and have the NOC doing the SOC? Well, the first thing is you need to try harder. You need to try harder to convince the management that basically these two are totally different. Just imagine that one police actually doing the traffic control, while the other one is doing the detective, doing the investigation. They totally have different mindset, different priorities, different skills. Same thing with NOC and the SOC. So you need to try harder and basically try to convince your management so that you will have one separate SOC. What happens if, let's say, you have tried, but then the decision is already final and you have nowhere else to go? First of all, try your best to maintain the separation of duties. How can you do that? You might give the, let's say, the NOC have access to routers. Don't give access to the person who's doing the SOC to other systems. Try to limit them. Try to use the least privilege possible whenever they need to perform their job. You can also develop an intense and extensive training to get them up to speed. The NOC need to be trained to be a security analyst. You need to train them so that they will be able to think like a security analyst. They will be able to see how an attack coming in, how does it look like from the intrusion detection perspective. And this could be very intense. Usually it take about 6 months minimum to get them up to speed, and usually about a year or two. If, let's say, you still have no choice, the SOC, NOC still has to be combined. The other thing you can do is create one dedicated engineering team. They will be responsible to monitor and to administer your IDS sensors, your database, and so on and so forth. So basically, the person who is doing the monitoring, the NOC, who usually has administrative privileges, they will not have access to all of this. They will not be able to modify any of the event log informations. Last thing we can do is continuously monitoring the groups. Basically, who's the watcher of the watcher? You need to let other people's, other groups, like the audit groups, you need to keep monitoring these people. While they're doing monitoring on their environment, they need to be watched. And lastly, because now you have two areas that you have to train the analysts on, at least half of the training budget will go to network, not on the security. And that will be quite a big loss. If you do it right, if you create your SOC and you do it right, actually you will spend fewer dollars with better result. You will be able to increase the skills and knowledge of the employees. How you do that? Because now they will be trained in two different areas. And basically for the analysts, they will know in depth on the particular field that they're working on. And you'll be able to see improvement in terms of the incident response capabilities. If there's a worm, you will be able to catch it right away. If there's hacking attempts, you'll be able to see that and will be able to detect those before anybody else does. And for that, only if you do it right. Risk, if you create the SOC and you do it wrong, you will waste a lot of your money basically. Because you put all the infrastructures, you put the IDS, you put all the hits and needs infrastructure, you dump all the firewalls into your correlation engine, but then at the end, you're not basically getting the ROI that you are intended. Having the SOC might give you false sense of security. You got people monitoring our environment, right? Are we secure? Actually not, because they don't know what they're looking at. So you might miss the attack after it's too late. If, let's say, there's a worm spreading in the environment, before the worm becomes worse, the basically propagation of the worm spreading all over the network, all over the enterprise, you already missed the detection, and basically it's been spreading all over the place. So the first event, the first detection is the most important one. And usually one of the most difficult one is basically new kind of worm, because you do not know how it behaves, how it propagates, what kind of systems actually it basically infecting, and how it's basically spreading. So having the SOC, if you do it right, you will get what you're looking for. But if you do it wrong, you're going to miss a lot of events. Lastly, it is possible, even though you have the SOC, you might violate the law. Like the new law, the Sarbanes-Oxley, for example. You might basically have the environment, you have the people doing monitoring, but actually, in terms of the compliance, you're not compliant to the law, because you miss all this detection that you are intended. Things that SOCs should do. First of all, they need to monitor the IDS logs. Those are the first thing they need to do. The second one is, among them, the firewall logs. Because what happens is, if you have an attack, you have, let's say, a malware, you have a hacking attempt, you will not see those in one technologies or one platform only. You might see it like a one spot on each one. You might not be able to understand what's going on. If you're looking at multiple events from different type of technologies, different type of logs, you will be able to correlate them and then understand what's going on. And this is why one of the reasons doing IDS is very difficult. The other thing the SOC should do, the analysts need to be trained, and they have to watch the security mailing list. All those codes, the exploits, they need to understand how it works and how it's propagated. How does it look from the IDS perspective? How does it look on the firewall log? How does it look on the honeypot and so on? Whatever that you have, that will play a role. For example, if there's a worm, usually it will try to connect to OpenShare. It will try to connect to vulnerable systems. And you can see some kind of propagation from there. The needs configuration need to be managed. If not by the SOC, need to be one dedicated engineering team to do that job. The hits, for example, will also complement the needs that you have. However, the overhead is a little bit more, because first of all, it's running on all the systems. If you have more than 100,000 systems, all the agents are running on all these nodes. So the most important thing is, before you deploy, you need to do extensive planning, testing, and deploy. So before you deploy, you need to do an extra job basically to make sure that it's working properly. And then you need to monitor the internal compliance to the information security policy. You need to set up the policy, and now basically that will be your baseline. You need to monitor those. And you can use your monitoring capabilities, the IDS, and things like that, to make sure that the policies are actually followed. And everybody's in compliance on that. You'll be mistaken if you ask the SOC people to do administrative stuff that violate the separation of duties, that basically require different skills to do administration stuff. That is not the job of the security people. What happens is, if they doing the administration stuff, their uptime is their priority, not the security monitoring. So if you do that, you're gonna miss a lot of security stuff. And you need to develop the information security policy for that. That will be your baseline. So in Intel, how do we create our SOC? First of all, when we decided to create a centralized team, we assembled a team to analyze the IDS output. We got the sensors from different technologies using whatever is available right now, which is the signature base, the protocol anomaly base, the network anomaly base, and a number of other technologies. So we have those logs, and we basically let the SOC people to monitor those logs. They will not be able to monitor the logs for one specific platform. So what we do is, we have correlation engine that basically we dump all the logs into one big database and we do correlation there. To find these people, we look for people with very strong technical skills, but actually no security background. They do not know how the attack works. They do not know basically how to detect those from the IDS perspective. So what we did is actually we hired the existing people, existing employees within the company, and moved them into one team, one centralized, dedicated team. And then what we did is we basically provide very extensive training to basically teach them necessary skills to do the job. So for that, what we did actually, we chose commercial tools to provide the capabilities that we need, that will basically be able to cover and monitor our whole environment. And those tools, some of them are actually very much customized for our environment. To look for the best people to do the SOC job, aptitude and experience. Those are two main things. You can basically teach the technical stuff, but the aptitude, you might not. What happened is, to know one technology, one specific technology is easy. To know several technologies is a little bit harder, but to know multiple technologies, and then you're able to learn new technologies and adapt to them is very challenging. What happened in security, things change by minute, by hour, not by days or by week. Things that we know today will be obsolete by the next few minutes. So you will deal with a lot of informations. You will deal with all the information coming from the mailing list that you basically monitor. You deal with the technologies. Previously we got IDS, now we got IPS. And all of this, you need to learn and adapt to them. And that even basically not enough. You need to come up with, you need to basically deal with other technologies. So because of this, things change so rapidly, people can get burned out very easily. So you have to plan, you must have a plan to address this issue before it's become too late. So when we come up with the SOC, we already address this so that people will not get burned out. So we know beforehand, if people actually been trained and then doing the job and keeping themselves up to date on everything that they're doing, they will get burned out. By looking this kind of people, who are the best to join your SOC, if they have more experience, the better, but you can teach them. So the main thing is the aptitude. The aptitude would be your significant basically point, which is very essential for a successful SOC. Whenever possible, try to hire experienced people. They've been dealing with some of this stuff, so that you can cut the cost. Pretty straightforward for that. But then, usually the experience will prove their ability to do the job. And the NOC skill, again, try to stress. If let's say they are from the NOC background, for example, we don't care much about how to configure a router, how to configure the network devices. We don't care much about that. Anybody can do that. Just give them the training materials, the routers, they can do that. But what we want is basically for them to look beyond that, what's going on in the background. What's happening with, if you look at the IDS stuff, they need to understand in depth about TCP/IP protocol, for example. How the TCP protocol works, how basically system establish the connections, and how basically hackers will be able to take advantage of these protocols to hack your system. So NOC again and SOC, they require totally different mindset, different skill, different mindset. And the most important one is their priorities are different. To have the best people to join the SOC team, you need to look for people who are very curious, who really want to learn, who really put the effort to learn. If let's say they basically want to join the team and basically they're not curious what will happen, they will be the candidate who will get burned out easily with the job responsibilities and the information overflow. So people who actually try to basically, if they have an issue, they have some problems, they will try to find the answer to those problems. They must be very, very curious on certain things. The second one is ethicals. Ethics cannot be taught. So when they're looking at the events, they're looking at the packet captures in your environment, they are looking at all this private and confidential informations. If they're really unethical, by basically having the capabilities of looking at packets in your network, it doesn't mean that you can just play around and look at everything. They need to be very, very ethical so that they will basically look at packets that are related or basically need to the information that they need to do the job or doing the investigation. If they're basically looking at everything else, that would be very, very unethical. And what happened is the privacy and the confidentiality will be broken. They might tell anybody else about what they found in the environment, and that can be a violation of the policy and could be the law that end up a prosecution. And these people, usually they like to do short-term projects, like to automate, to do correlation, things like that. The analysts, again, they will face a lot of frustrations in doing their job. They're looking at a lot of data, but each data, each packet, each event that they're looking at is basically representing just represent a very little piece of the puzzle. Just imagine that you are basically looking at the iceberg. What you're seeing is only 10%, and the 90% is actually underwater. But basically, when you're looking at these events, you're just looking at very small percentage. Just imagine that when you're doing the IDS log analysis, the log was basically triggered by looking at certain information on the TCP header, for example. You're just looking at the minimum is 4 bits of information that can trigger a log, and that actually represents the whole packet, which is up to 1500 bytes for IP packets. So there might be a potential of frustration, looking at certain things, not enough information to come up with the conclusions. And they must be comfortable with not being the expert. They need to know a lot about different things. They need to know about programming, how basically buffer overflows works. Not exactly how to basically write a buffer overflows, but they need to know how it works. They need to know the Windows platform environments. They need to know Unix. They need to know Linux. They need to know any other operating systems. They need to know how the routers works and how basically fragmentations works down to the TCP/IP level and so on and so forth. So they need to know almost everything. So that's almost impossible for them to be an expert in certain areas. They need to know almost everything, so they must be comfortable to know that they know a little bit of everything. So for that, they should be able to identify pattern. The pattern of, let's say, an attack. Just looking at certain logs on the behavior of the malware, for example, they should be able to solve the puzzle. So that requires a very, very technical and also experience to get into that. When you train your analysts, do not try to basically rush. Try to rush the training and say, we got all this training set, week after week, product after product, technologies after technologies. And then once we're done with the training, I think we're ready to go for our SOC. That would be a big mistake. What happened is, if you're doing just the training, one after another, they do not have the experience of analyzing the real thing in the environment. So it's much better, if you already have your SOC set up, try to do on-the-job training. Shadowing the analyst doing the job, and then encourage them to do the certification that's related to the job. One good certification is basically offered by SENSE, the intrusion detection in depth. Will give you insight of the IDS work. The product specific training is actually secondary. If, let's say, you have one specific technologies that you want to use, product from different vendor, that is secondary. The main thing is you need to know two things. When the product will likely to make mistakes, what it doesn't cover. If it's a network IDS, for example, if it's a signature base, what will this product will miss? What it doesn't detect. If it's a protocol anomaly that you choose, that type of product, what is the weaknesses of this product? You need to know this so that you know what are the negative events that you will miss in your detection. And secondly, you need to recognize when there's a mistakes actually happened by mislabeling the problems. You need to deal with it. So for example, let's say for IPS, that inline IPS allow you to prevent an attack. That can create denial of service in your network. If that happened, how to basically undo the whole thing so that get your network working again. The training is a very lengthy process. It takes a while for them to know what they're doing, for a while for them to familiarize themselves with all operating systems, all the network protocols, the attacking techniques, the programming languages, the databases, the IDS, and then from the investigation side, chain of custody issues that they have to basically maintain, so that if there's event that basically need to be used in the court of law, you'll be able to use it. The ethics issues, the services, the investigation processes, the application, and more. So the IDS analyst who's doing the SOC job right now need to know almost everything. So for that reason, you will need to basically continuously and extensively training these people. No matter where you find the people, and basically how you find the people, not really how, but basically where you find these people and basically bring them into your team, but then you need to do continuous training. The IDS analysts in your SOC, they must learn how to analyze the intrusion and IDS alerts. These skills not taught in any schools. Try to find this kind of course in any universities. You won't find one. So for this kind of job, the first thing they need to do is they need to find out and teach them how to do the analysis. What are rights? What are those alerts are wrong? What are the partially wrong? The right and wrong are pretty easy, straightforward, but partially wrong is difficult. So the best thing to do in your training to train these people will be on-the-job training. And you'll be able to pinpoint them. These are actually how it looked like in your IDS. So for this reason, there are suppliers that basically specialize in security training, like the SENSE course that I mentioned earlier. And if you look for this kind of people, look for their certification, look for the goal, which require them to write a paper. And you can see how in-depth their understanding about the skills that they have learned compared to just the silver certification or the GCIA silver certification. That only they have to sit for 2 exams and they will got the silver. But if they got the gold, they will have to analyze millions of alerts in different type of format, and they have to come up with a conclusion. From there, you can learn how much this person knows about what they are writing about. Okay, the BKMs. In the group, you need to start with the person with the best experience in the intrusion analysis and use them to become the seed to build the skills to the rest of the team members. You need to start with one person at least, and you cannot have one team and nobody has any experiences in IDS. They will not know to do anything. Even if you send them to do a training, the training is totally different than the real environment. They will not be able to differentiate between an attack and false positive, for example. And they will not be able to differentiate if, let's say, there's a false negative in their detection, that they missed all this detection of the attacks in the environment. They will not be able to do that. The products doesn't basically not always has to come from a supplier. The knowledge of the products doesn't have to come from the suppliers themselves. The best knowledge actually in this SOC team would be the third-party training vendors, because they are non-biased to the product and they're basically doing a lot more in-depth analysis that will be included in the training. So having a third-party training vendor will be much more beneficial for you for this type of task. Again, for the independent certification, look for the one that require the candidate or the analyst to write a paper. This would be a method for you to know how much they have absorbed the materials, because the materials is very in-depth, require a lot of experiences and knowledge in TCP/IP, DNS, and so on. Okay, so if, let's say, you have analysts from, one is from the development background, the second from multi-platform system administration, for example. By having these two environments, it will basically help you to reduce the cost of trainings. And much better if, let's say, the team consists of people from different backgrounds. That way they can basically complement each other and having a much stronger team. The network administration skills is not really important here. We do not really want people to know how to configure stuff, but we want to know, we want people who knows how things work and how things don't work as designed. So we need to know that they have the knowledge much more in depth than just configuration or system administration. By knowing that skill, it will not help. So again, you need to have a pool of people with different background, different skills, and then you can cross-train them. And they can teach each other the background and the skills, and that will complement and make the team stronger. So what we have learned in Intel, basically, by putting the processes, when we basically set up the SOC, we try to come up with all possible processes that will be required to get the job done. We need to have the processes to deal with the tool. We need to have processes to deal with the emergency response. We need to have processes to deal with the HR if it involves an employee, with investigation or the investigation from the corporate security. So we have those processes in place so that when we set up the SOC, we have those ready. And actually, you can basically build or modify that, rectify those processes as you go. But you need to have them when you set up your SOC. And this work need to be done, or they will be doing similar things many times. And for that, you can customize, borrow certain things, and then customize those processes in different areas, so that you don't have basically start from scratch. You can just basically steal some time there. Some of the processes that we found is very necessary for this SOC. One is the customer engagement, the tuning, the initial and ongoing, the incident handling, information sharing, the knowledge that's being captured, administration of the systems, and also the evidence handling. All of this will be among the top processes that need to be available. And for the disaster recovery and business continuity, you can basically depends on everything on electronic copies. You need to have hard copies just in case if your system is not available. So the disaster recovery and business continuity will have to be part of your planning when you set up your SOC. So when you set up the SOC, there's a higher possibility that basically a lot of groups in the enterprise will be impacted. So first thing you need to do is have like a kickoff day where you gather all the groups involved and talk about it. It's much better for you to talk beforehand rather than you miss some groups and then you got some feedback saying that, hey, I'm not even aware that there's SOC doing the monitoring here. And all these people, when you basically talk to them beforehand, they will provide you data, information about their environment, and that will basically help you a lot. So among the top groups, most important groups that you need to get them involved, among them are the human resources, the legal team, where the lawyers are, the internal audits, who are doing the audit for you, and the physical security. These will be your top priorities. Tools will be very important for you to do the job. Without the tools, you will not be able to perform. The proper tools has to be there and available. However, the SOC tools, if you look at it, is not yet mature. There's no such thing that will be able to do everything that you want to do. So these tools will be most important, and there are some requirements that need to be in your tools, such that the tools will allow you to do correlations, will allow you to extend the correlation that you're doing, allow you to do, basically, you can combine a number of products and basically get the things that you're trying to do. Basically, collaboration between the tools should also be among the top priorities. Because you're doing the security monitoring for your enterprise, BCDR again is really important for you. And if, let's say, the analyst is not available, they need to be able to perform the job remotely. If, let's say, there's a downtime or there's a crisis in the office areas, they will have to do the job while they are mobile. So the key features for the tools, everything must be extensible. You can extend the tools to whatever you need in the future. Visualization will help you a lot, because when you're looking at millions of alerts a day, you can basically see that in much better easy way to understand what's going on there. The IDS alert categorization is also an important one. A second here. The IDS alert categorization schema is really important for you to do the correlation. That will be the basic of your correlation rules. When you set up your rules, you use the schema to look for certain things that you're looking for. One example is before let's say a malware or worm start propagating in your network. The first thing you will do is you will do scanning of your network. See if there's any live system in the network, in the LAN, WAN, whatever, and then it will start. Once it found live systems and found the systems vulnerable to the attack, and it will start sending out the exploit. So you can see the first criteria or the category what the system is doing is basically scanning. You will see post scanning, you will see some other type of scan. Once the scan seen in your IDS, you will see some other activities. So those will be part of your correlation. The ticketing system, once you have all this detected, once you have the systems basically monitored, and then you have the logs, you will need to have some kind of way to keep track of what you have found, what you have detected in the environment, and usually all of this information will be necessary for you to come up with metrics. You need to come up with some data saying how many events been detected, how many actually been investigated, and how many actually maybe the hackers or the malware has been detected, so on and so forth. So the ticketing system must be integrated into the system, and the knowledge base must be there and available to support the analyst. Once they see an alert, they will not know everything. There are thousands of alerts, different type, category, and different type of events. So when they see one alert, they will basically be able to open up the knowledge base, and they can see, get some more information on what's going on. That will help your analyst. The knowledge base will be fully researchable, not just by topics, by keyword. They need to be, each of the words should be searchable in your database. The reason is, when you try to search certain things, some of the information that you look for does not necessarily added into the keyword. You will not be able to find what you're looking for. One good example is if you go to the securityfocus.com, you look for the vulnerability list, and you will see a long page of information, what type of operating system or application that might be vulnerable to the attack or to the exploit. And they have some explanation, things like that. If you got the keyword wrong, you will get the wrong thing. So that's why the knowledge base must be fully searchable. Okay, the tools again, the discussion forums. If let's say you have discussion forums within your enterprise talking about discussion on what they have found, things like that, need to be integrated into the knowledge base. Discussion forum XML, talk about the exploit, the vulnerability list, the bug tracks. Those need to be in the knowledge base. So your knowledge base must be extensible and also contain a lot of information. And just like any other companies, lab usually will be the last priority if it's not basically not involving a new product, something like that. Lab will be last priority for you. But if you can, whenever possible, try to have a lab so that you can basically verify and validate what you have found, and verify and validate whatever that basically you're looking for. For example, is if you have exploit available, just been released in the wild, you do not know how that exploit will be taken advantage by the hackers. So you will be able to produce the IDS signatures in the lab just from testing those exploit in your lab. So in your lab, you need to have all the basically the tools that you have in your production. If you have the needs, that particular vendors, for example, you need to have those in your lab. If you have the hits, you need to have those in the lab. If you have the firewall and so on and so forth, those need to be available in your lab. Okay, so now versus before the SOC. So before the SOC, if you look at it, how long it takes for you to compare, how long it takes for you to detect an incident and identify this incident correctly. If let's say one particular worm basically propagated and basically spreading in your network, how long it takes for you to detect that you have this worm in your environment compared to after your SOC. So this is one of the criteria of measuring the success of your SOC. And how long it takes for the SOC to address the incident. Once they see one particular detect, how long it takes them to analyze the logs and come up with a conclusion, say, hey, this particular worm is actually spreading in our environment, and we need to take action, isolate the network, for example, and then basically eradicate the worm. How long it takes for them to do that. So those will be one of the measuring success. And then you need to have some kind of qualitative evaluation on how easy to coordinate the incident. Having the SOC, don't just basically let them just do the job and you basically let go, let them do their job alone. What happens is they might miss a lot of attacks. One way to basically to check whether they are actually performing is you do the attack yourself to see if they are able to detect you. So you try to sneak into the IDS and also the monitoring systems to see if you can bypass the detection. If you're able to bypass that, you will have some issues. So some other metrics you can look at is number of alerts handled, how many analysts doing this particular tickets, how long it takes them to resolve the issues. For the whole group, how many they have done that, how many they can come up doing this investigation during a day, and so on and so forth. Number of system, network, IP addresses monitored. One particular ticket might involve multiple systems, might involve multiple type of attack. One such example is, let's say you have TFN, Trino flood network, for example. You might see one packet saying echo reply being sent from the master. But then from that, you will see a lot of event coming from the agent and creating distributed denial of service on one particular machine. So even though it's one event, one incident, but then you will see a lot of alerts generated. And to correlate those events and to come up with a conclusion that, oh, this is the master of the TFN and this is the agent of the TFN, will be very difficult. So by just looking at the number of tickets, actually you cannot basically use that your only metrics to tell that basically your SOC analysts are doing the job. Try to basically deduce and come up with conclusion with the whole thing, which is a very difficult thing to do. So this whole picture, actually, the whole model will never show the real picture. And this is why the IDS analysts will require extensive, or maybe I would say all-rounder. They need to know a lot of things. What I'm trying to show here is the technical skills and the level required to be a good and successful IDS analyst. In terms of programming, database, network protocols, Linux OS or platform, Unix, Windows, the directory services, assembly languages, the IDS, exploit code, services, and many more. They need to know all of this. So this will be the, one is the minimum level to be an IDS analyst. The second one is to be an ideal or effective IDS analyst. And this is basically some of the information or the skills that they require. So almost done here. So whenever you make a filter, you make an exception, you need to keep track of those. So when you did the filter and set it up on your sensor, you need to keep track of those just in case. If something happened, you need to go back and check what I have done that basically causing us to miss this attack. And when you're creating new rules, correlation rules, you need to create and validate those. Again, I'd like to stress the importance of having those capabilities in the lab so that you can basically validate those before you put it on productions. In conclusion, the separation of duties is one critical factor for the SOC. You need to keep those in mind. And then try to decide whether you want to build or rent, which is outsource the SOC. You have heard about the pros and cons. And the best way to ensure failure is under-resourced. If you try to basically set up your SOC, but you're not putting enough resources to it, you basically end up having some failures on that. And you can start with one person, one good analyst that will be able to share the information and train other people. And then processes, really important, and those has to be in place before you set up your SOC and basically go to productions. Technical skills, less important than aptitude, curious to know things, try to find solutions to problems, those are more important than the technical skills. And the more data provided to the analyst, the better. And you need to be aware of potential to get burned out from information overflow. And try to prepare everything ahead of time so that when you approach or you're basically facing that kind of difficulties, different issues, you have everything set up. The disaster recoveries, you have processes in place, things like that. And lastly, the communication between the analysts is the key. You have to have a very flawless communication flow between the analysts to share with what's their findings, and that is really important to have a successful SOC. So by that, I close the presentation. Thank you very much.